There's something quietly alive at the edge of the sun's glare. A faint shimmer, barely seen by telescopes, yet strong enough to stir every astronomer's curiosity. They call it Three-Eye Atlas, the third visitor known to come from beyond our solar system. It arrived like a ghost with no warning, slipping between the orbits of planets, leaving behind trails of gases that no one expected to see. For weeks it stayed hidden, until one night the instruments caught something impossible. A faint breath, a chemical whisper not found in any comet born of our own sun. What is this traveler trying to tell us? Why is it emitting gases that don't belong here? Tonight we'll drift into that mystery together, slowly, like space itself, unfolding. We'll follow its trail from the moment it was found, through its strange awakening, and into the heart of what it might reveal about life, chemistry, and the memory of distant stars. It began as a blur, a faint, elongated glow, tucked dangerously close to the sun's blinding face. Most telescopes looked past it, dismissing the light as interference or sensor noise. But then something subtle shifted. Its path didn't match any known asteroid, and its brightness flickered in patterns too deliberate for random sunlight reflection. Within hours, data analysts confirmed this was something from beyond, a traveler moving too fast to be bound by gravity. And yet it seemed to pause, as if curious itself, lingering in the magnetic wind of a foreign star. For astronomers, discovery always starts with disbelief. They compared images from Chile, Hawaii, and orbiting satellites. And there it was again, the same wandering signature near the sun's edge, pulsing faintly as if breathing light. Observers whispered that this wasn't an ordinary object. It behaved as though it was responding to the sun's presence. Something deep in its material seemed to wake up under that fierce radiation. For a moment, science felt small again, standing before a mystery that didn't fit into its equations. Each night that followed brought a slightly stronger glow, as though the visitor was growing more confident in its reveal. Its movement was precise, not tumbling like Oumuamua once did, but turning gently, controlled, as if guided by invisible symmetry. There was something graceful about its path, something that didn't feel mechanical at all. The silence around it felt almost deliberate, as if the object was waiting for us to notice. When data from the Solar Terrestrial Observatory arrived, the pattern was undeniable, a trail forming behind the light, thin and irregular, yet unmistakably gaseous. Whatever this was, it was shedding material, even in the sun's harsh radiation field. The gases weren't behaving like dust. They shimmered differently under ultraviolet observation. It was as though the object carried chemistry that didn't belong here, something not made in our sun's nursery. So the question formed quietly in every observatory room across the world. Was this just another comet burning under solar heat? Or was it a message, in chemistry, from a star system far older and colder than ours? The truth shimmered in its trail, like a story written in invisible ink, waiting for warmth to make it appear. By the time official confirmation came, dawn had already painted the Chilean desert gold. The announcement read like a heartbeat of history. Three-Eye Atlas confirmed. The I stood for interstellar, a word that still carried the weight of wonder. Only 2 others had ever crossed our system before. Yet this one was different from the start. It wasn't racing through space, it was gliding, taking its time, as if it belonged here. Scientists called it an intruder. Some whispered it felt more like a guest. At the Atlas Observatory, data poured in. Coordinates, magnitudes, angles of reflection. But behind the numbers was something poetic. This thing had come from a region no one had mapped, between constellations older than language. Its speed was higher than any bound comet, but its composition looked wrong. The first spectra showed unusual absorption lines, light being eaten by gases not found in our solar system's catalogue. It was as if the object carried the signature of another sun entirely. You could almost imagine it travelling for millions of years, drifting through emptiness, gathering dust and memories of passing stars. When it finally entered our domain, it met our solar wind like a stranger walking into a storm. The gases began to move, shimmer and twist, forming a cloud that almost seemed to breathe. Astronomers began to argue. Was it alive, chemically, in the way certain reactions mimic life? Or was it just coincidence, a beautiful illusion of motion in a lifeless dance? The more they looked, the stranger it grew. The object reflected sunlight in bursts, as though layers of volatile ice were cracking open one by one. Every turn of its path revealed new materials escaping. Methane, ammonia, carbon monoxide, but in ratios that made no sense. Even the computer models couldn't predict its next emission. For a while, all anyone could do was watch and take notes, waiting for the pattern to reveal itself. And as the days passed, it felt as though the object had become aware of its observers. Its emissions pulsed when our sun erupted with small flares, as if reacting to the solar rhythm. Coincidence, perhaps? Or a reminder that even across billions of miles the universe still dances to the same invisible beat. When astronomers describe light as wrong, you know something unusual is happening. 3I Atlas was supposed to brighten predictably, comets always do, but instead it pulsed, then dimmed, then brightened again, each change slow, deliberate, like breathing. The glow didn't spread uniformly, it clustered in arcs, faint halos surrounding a darker core. It was as though the light itself was struggling to escape whatever held it. Some compared it to bioluminescent life in the deep ocean, how organisms release light not for visibility, but as communication. The thought lingered longer than anyone admitted aloud. Could gases interact in such a way that they formed their own rhythm, their own voice in the vacuum? The data didn't fit any known photochemical model. Even the dust ratios seemed inverted, heavy materials where light ones should be. As if it had been built in a reversed environment, under a different kind of star entirely. Satellites watching from different angles showed something even stranger. A faint polarization in its glow, a twisting pattern suggesting electromagnetic alignment. That meant the gases weren't random, they were aligning to fields, responding like tiny compass needles. 3I Atlas wasn't just emitting, it was interacting, tuning itself to our solar wind as though testing it. Some called it learning light, others, more poetic, called it listening. And yet amid all this curiosity there was silence. No radio signals, no coherent emissions beyond natural frequencies, just light behaving like thought. It was frustrating and thrilling. Every scientist who looked at it felt both lost and found at the same time. The mystery wasn't just in what they saw, but in how the object seemed to anticipate being seen, like something ancient, rediscovering its reflection in a new sun's mirror. The object, in its silence, was teaching something, that not all communication is loud. Some of it flickers quietly between wavelengths, hidden in the way gas bends light. And maybe that's how the universe speaks, softly, through the chemistry of things that drift between the stars. When the spectrometer readings arrived, the lab fell silent. The numbers didn't make sense. They weren't matching any standard chemical database. Peaks appeared where none should, valleys where light should have passed freely. Carbon monoxide, yes, but mixed with nitrogen oxides and a faint signature of cyanogen, a compound that hinted at high-energy reactions. Then came the shock. traces of noble gases like argon and xenon in unexpected quantities. Those are usually trapped deep within ice, not released this early. Something deep was stirring inside 3I Atlas. The gas ratios suggested internal heat beyond what sunlight alone could cause. That meant radioactive decay, or energy stored from its birth near another star. If true, this object wasn't just frozen memory, it was active, evolving. It had chemistry alive with movement. The gases expanded in layers, curling around the nucleus like veils, sometimes stretching miles long. Instruments caught tiny changes in velocity within those emissions, as if waves of release were timed, pulsing at intervals. Observers described it almost poetically, a comet with a heartbeat. You could see it in the way the coma brightened in cycles, the gases releasing like breath under invisible command. No other interstellar visitor had done this before. It wasn't chaotic, it was graceful, consistent. Every pulse released slightly different elements, like an ancient machine venting messages in vapor. Laboratory simulations failed to reproduce the pattern. Even when exposed to the same solar intensity, analog materials refused to behave similarly. The team concluded that the gases might contain compounds unknown in our system, perhaps formed in colder, denser regions of another galaxy's arm. A strange thought lingered. If it carried elements forged under different physics, what might they tell us about creation itself? Somewhere inside that glowing cloud, atomic histories older than our sun were unfolding. Every molecule released from 3I Atlas was a story or teed about pressure, time, and silence. And as those stories drifted outward, they mixed with our own solar wind, rewriting, molecule by molecule, the chemistry of our neighborhood. By early October, telescopes across the world were whispering in unison. They all wanted one thing, a clear view of 3I Atlas. Yet it was still hidden, lost in the glare near the sun. Only a few lucky spacecraft caught glimpses, and what they found deepened the riddle. The gases weren't fading with distance, they were increasing. Usually, a comet slows down as it releases more material, but this one grew more luminous, more expressive, as if the heat was giving it strength. Somewhere between Earth and Mars, this faint traveler began to define a new kind of beauty. Amateur astronomers would stay awake at night, pointing cameras at the dim corner of dawn, hoping for a hint of movement. For many, it wasn't about data anymore, it was about wonder. They were watching a piece of another solar system breathe inside ours, and that in itself felt holy. Researchers noticed something delicate. Every time our sun sent out a small flare, the emissions around 3I Atlas flickered in sync. It was too precise to ignore. Was it reacting? Or was this some resonance, an invisible harmony between two stars? One burning, one remembering? The thought spread quietly through observatories like a rumor the universe wanted us to hear. Now, every instrument was tuned to this visitor. The gases were teaching lessons in chemistry and patience, revealing elements of the unknown. Spectra showed faint traces of deuterium-rich ice, hints of prebiotic molecules, and something else, a vibration in infrared that scientists couldn't identify. Some called it a cosmic accent, a dialect of chemistry not spoken here. And so an invisible speck near Mars became a mirror, reflecting not light, but curiosity back toward us. 3I Atlas had arrived not just as a visitor, but as a teacher. Ahead in this video, we'll open the deeper layers of its strange emissions, its hidden memory of other suns, and what its breath might reveal about how the universe keeps secrets alive. When scientists say a comet has started breathing, they don't mean it's alive. Not in the way we are, they mean it's waking. Sunlight reaching the deep layers of ancient ice, warming them just enough to release gas that's been trapped for millions of years. But 3I Atlas was different. Its breath wasn't gentle. It exhaled in pulses, uneven but rhythmic, as if each release followed an unseen timer. The gases didn't drift away quietly. They moved with direction, almost like they remembered where to go. Astronomers compared the rhythm to a slow heartbeat. A wave of material would expand, fade, then return stronger. No known comet behaves this way. Some suggested it might be spinning, venting jets from rotating sides, but the timing didn't fit. Others thought it was responding to solar wind, yet that too couldn't explain the precision of its breathing pattern. Every burst seemed calculated, not chaotic. It was as if 3i Atlas was practicing something ancient, the physics of persistence in silence. From a distance, the gases glowed in soft turquoise hues. That color told a story, cyanogen mixed with diatomic carbon, reacting with sunlight. Beautiful, but deadly to life as we know it. And yet, watching it shimmer was mesmerizing, like a creature from before memory, stretching after a long sleep. Some scientists stayed up for days, replaying the spectral graphs, searching for any sign of repetition, any clue that this breathing had meaning beyond chemistry. When the data came back, one fact stood clear. The intervals between pulses matched a recurring solar frequency known as the 5-minute oscillation, a vibration from the sun itself. Somehow, across millions of miles, 3i Atlas seemed to mirror the sun's rhythm. Coincidence, maybe. But it made everyone stop. Could it be that even interstellar objects still carry the memory of stars? That they resonate to the same universal heartbeat? In that moment, the idea of breathing felt less metaphor and more truth. Space was not stillness, it was respiration at a cosmic scale. Every flare, every gas jet, every flicker of light, an inhale and exhale of creation itself. And 3i Atlas had simply joined in. As 3i Atlas approached the inner solar system, something impossible began to happen. Compounds that should have remained frozen even at those distances, nitrogen, argon, carbon monoxide, started evaporating rapidly. Under ordinary physics, these materials need far more heat than sunlight could offer at that range. Yet sensors recorded plumes of vapor expanding outward at hundreds of meters per second. The comet wasn't just warming, it was reacting to something unseen. It puzzled scientists because each gas emitted at a different depth in the nucleus. That meant multiple temperature zones, like layers inside a living body. The comet wasn't melting uniformly, it was selective. Some layers ignited while others stayed quiet, as though an inner system of thresholds governed what could be released and when. If this was purely natural, it was the most complex example of spontaneous thermal dynamics ever seen. One hypothesis suggested a radioactive core, isotopes decaying slowly, releasing internal warmth. Another proposed a chemical trigger, exotic ices combining under pressure. Yet none could explain the synchronicity of release. The emissions weren't random bursts, they followed patterns like chords struck in sequence. That rhythm haunted the data, subtle yet undeniable. It was chemistry with intention written into its chaos. Even more curious were the infrared readings, and they showed certain gases glowing hotter than they should, as though energy was being generated from within the gas itself. Some compared it to phosphorescence, others to an internal reaction similar to cold plasma discharge. Whatever it was, it hinted that 3i Atlas contained energy sources unfamiliar to us, the kind that might form only under alien suns. It's strange to think of ice behaving like fire, but that's exactly what was happening. Frozen elements, born under ancient light, now burning cold in our warmth. 3i Atlas reminded everyone that the line between solid and vapor, between stillness and reaction, is thinner than we imagine. Sometimes all it takes is a star's gaze to make an object remember what it once was. When the spectral data from 3i Atlas was first translated into visible graphs, it felt like deciphering a new alphabet. There were peaks in wavelengths no one recognized, lines that didn't correspond to any molecules catalogued in our system. Some scientists thought the data was corrupted, but after days of verification, it became clear the object's chemistry was genuinely foreign. It carried compounds we've never seen up close before. The most striking difference was in its carbon and nitrogen ratios. They were far too high, suggesting formation in an environment rich in cold organic dust, possibly near a dying red giant star. In that kind of cradle, atoms are rearranged under slow, heavy light, creating molecular architectures our chemistry barely understands. It was like finding handwriting from another universe. Every atom in those gases was a syllable of an unknown language. There were hints of complex hydrocarbons too, long carbon chains similar to tholins, the reddish material found on Titan and Pluto. But here they were purer, unoxidized, almost youthful. They hadn't been weathered by cosmic rays as much as local comets. That suggested 3i Atlas had spent eons in deep interstellar cold, shielded by magnetic dust clouds before entering our system, a pristine messenger from the galactic dark. The more the data unfolded, the more it resembled a confession from another cosmos. Silicon appeared where oxygen should be dominant. The spectral ratio between iron and nickel reversed our planetary pattern entirely. Even isotopic measurements whispered of a chemistry that obeyed different balances, as if the periodic table itself had regional dialects across the stars. It's humbling, realizing how small our scientific language still is. Each spectral line from 3i Atlas wasn't just data, it was proof that nature speaks in many accents. And now we were hearing one of its rarest voices carried across eternity, dissolving softly in the light of our sun. If we could stand near 3i Atlas, close enough to feel the faint touch of its vapor, it might smell sharp, metallic, maybe a little like burnt ozone and frozen steel. Of course, scent doesn't travel through space, but instruments capture the chemistry that could form one. The data painted an odd perfume. Nitrogen compounds, carbon monoxide, and traces of something that scientists could only label as unidentified volatile group A. It was, quite literally, an alien fragrance. These molecules behaved strangely when hit by sunlight. They didn't just scatter light, they refracted it into uneven halos, giving the comet's tail a greenish tint unlike any known mixture. Nitrogen should fade under this heat, but it stayed. Carbon monoxide should disperse quickly, yet it clung near the nucleus, shimmering like mist trapped under invisible pressure. Something was binding them together, a hidden cohesion beyond chemistry's normal rules. Speculations range from exotic ionic bonding to unknown magnetic influences. Some even suggested quantum-level coherence, molecules moving in synchronized spin states, defying randomness. While it sounds like science fiction, the measurements were real. The way these gases behaved couldn't be explained by classical models. It was as though 3i Atlas carried a tiny echo of the physical laws from its birthplace, operating slightly out of tune with our own. What fascinated many wasn't just the what, but the why. Why did these compounds persist so close to the Sun when every model said they should be destroyed? Perhaps, scientists mused, they weren't simple molecules at all, but clusters, protective shells of complex chemistry adapted to survive in multiple environments. In a strange way, they behaved like resilient travelers themselves. The object was no longer a silent rock. It was an aroma in physics, a composition of invisible taste and sound, reminding us that even in a vacuum, expression exists. The gases carried memory, and through them, 3I Atlas was quietly telling us its story molecule by molecule. At first, the phrase sounded poetic, an alien lung, but it came from a real observation. The gases emerging from 3I Atlas weren't released in chaos. They expanded in symmetric bursts, spreading evenly in all directions, then pulling back slightly before the next wave. That rhythm mirrored something biological, like respiration. The comet seemed to inhale solar energy and exhale vapor. Scientists began jokingly calling it the galaxy's slowest breather. But the deeper they studied it, the more the metaphor started to feel like a model. The core was layered, ice, dust, and perhaps a hollow cavity acting like a pressure chamber. When sunlight reached those chambers, it heated trapped gases until they escaped in pulses, not unlike lungs exhaling carbon dioxide. The timing, precision, and regularity turned it from a poetic comparison into a working theory. 3I Atlas might literally function as a natural breathing mechanism built by physics. Each exhale released gases that cooled rapidly, condensing back toward the surface and forming frost. Its version of inhaling. A cycle of renewal. Over time, this loop could even stabilize the object's rotation, like a self-balancing rhythm. The comet wasn't alive, but it had something lifelike. Balance through repetition, stability through breath. Even the energy readings supported this picture. The comet's thermal map showed alternating hot and cold zones that matched the emission cycles almost perfectly. That kind of regularity isn't random. It's rhythm born of feedback. The same principle life uses scaled up to cosmic proportions. It's the universe's quiet way of repeating patterns it knows work. And so when astronomers called it an alien lung, they didn't mean imagination, they meant recognition. A pattern of respiration seen not in cells but in stars, comets, and worlds, because perhaps the cosmos itself breathes through everything it creates. Ahead in this video, we'll move deeper into what these gases are made of, the colors they emit, the secrets they hide, and why the light from 3I Atlas might be the most important clue of all. When light from 3I Atlas passed through spectrographs, it painted colors that shouldn't exist. Instead of the expected yellows and blues of ordinary comet gases, the instruments caught something strange, teal fading into violet, threaded with thin ribbons of gold. These weren't just beautiful, they were physically confusing. Each color corresponds to a wavelength emitted by a molecule, but these wavelengths didn't match anything on Earth or in known cosmic catalogues. It was like hearing a song with notes that don't fit our scale, yet somehow sound harmonious. The initial reaction was disbelief. Scientists rechecked their calibrations, swapped sensors, even suspected interference from satellites. But no error appeared. The light was real, consistent, and deeply unearthly. Its intensity changed slightly every hour, like the shimmer of oil underwater, a subtle dance of color across invisible wavelengths. Some described it as living light, as though the gases were rearranging themselves faster than instruments could read. If the laws of chemistry were the alphabet, 3I Atlas was writing in a forgotten dialect. Spectrochemical analysis hinted at compounds that combine carbon and nitrogen in unstable ways, molecules that shouldn't survive long enough to emit light, yet here they were, glowing softly, over and over again. Their resilience baffled researchers. The glow carried hints of rare isotopes, heavy forms of hydrogen and oxygen that trace back to regions near supernova remnants. It was possible that these gases were forged under extreme radiation, hardened by the death of stars. Some astronomers felt uneasy. The more they watched, the more the colors seemed to respond, brightening when the sun flared, dimming during solar calm. It was as if the comet was in conversation with the sun's pulse, mimicking the solar mood in real time. Whether physical or coincidental, it gave the illusion of awareness, of participation in a dialogue billions of kilometers wide, and in the middle of this cosmic exchange, a new understanding quietly emerged. That light itself can be language. That every color from 3i Atlas might be a message from a chemistry older than life, still speaking through frequencies no one had ever heard before. As 3i Atlas drifted deeper into sunlight, its coma, the glowing halo surrounding its body, transformed into a hypnotic blue-green mist. At first, astronomers assumed it was the usual diatomic carbon, which glows green when sunlight breaks its bonds. But this was different. The hue was too vibrant, too steady. Under high-resolution imaging, the glow rippled like northern lights. It wasn't static light, it was motion, a breathing aurora shimmering in vacuum. The pattern looked familiar to anyone who had ever watched Earth's polar skies. Vertical curtains of energy bending under magnetism. But in space, there's no atmosphere to paint such effects. That meant something unusual was shaping the glow. A magnetic field or charged particles released from within. 3i Atlas wasn't supposed to have a magnetic signature, yet instruments detected faint alignments in its tail, consistent with localized plasma interactions. It was as if the object carried its own auroral halo, a small magnetic memory from its home system. When ultraviolet cameras captured it, the sight was surreal. The comet looked alive, its coma twisting in rhythm with solar wind, glowing brighter whenever a gust of radiation passed. You could almost imagine it dancing, adjusting its position slightly as if resisting the current. In those moments, the cold rock became something else, a dynamic sculpture of light and magnetism caught in a cosmic conversation with the sun. Scientists began to wonder whether 3i Atlas was magnetic by nature, perhaps formed near a stellar remnant, a neutron-rich region where magnetic fields shape matter. If true, that would mean this comet was born under conditions unlike anything in our solar history. Its magnetism could be the reason its gases behaved so intelligently, aligning and realigning, creating order from chaos. Watching it unfold was humbling. A frozen traveler creating auroras without air, music without sound. It reminded everyone that beauty doesn't need witnesses to exist. It simply happens, patiently, perfectly, even in silence billions of miles away. When scientists pointed ultraviolet detectors toward 3i Atlas, the readings came back in whispers, faint, flickering signals that grew stronger with each orbit of sunlight. Most comets emit predictable UV lines from hydrogen, oxygen, and carbon, but 3i Atlas sang a different tune. Its emissions came from unknown transitions, molecules so delicate they only survive in interstellar cold, and yet here they were, glowing near our star, refusing to break down. It was like watching frost bloom on fire. The ultraviolet spectrum revealed patterns almost poetic, triplets of lines repeating in fractal-like intervals. Some believed these were resonances of molecular clusters, tiny groups vibrating together like harmonies. Others thought it was quantum interference, overlapping photons creating patterns beyond human control. Whatever the cause, it defied textbook explanations. The data showed beauty so complex it became a mystery, a mathematical art form born from alien chemistry. What stunned everyone most was the stability. Normally, radiation this intense would shred molecules instantly, but these held together as if protected by invisible shielding. Maybe they contained metallic cores, microscopic iron, or magnesium trapped within, absorbing energy and releasing it slowly. Or maybe, just maybe, the laws of chemistry were slightly different where this comet was born, tuned to another frequency of stability, another rhythm of existence. It's strange how the smallest details can shift our sense of belonging. These ultraviolet whispers reminded us that the universe has infinite dialects, and we're fluent in only one. To listen to something like this is to realize how little we've actually heard, how much light still speaks beyond our translation. Each photon that left 3i Atlas carried the echo of another world, its sunlight, its physics, its silence. And here, under our sun, it was finally finding a new voice, invisible to the eye, but bright in the soul of anyone who dared to listen. The deeper astronomers studied 3i Atlas, the more one haunting idea returned. This wasn't just any interstellar wanderer. The isotopic ratios in its gases pointed toward origins near a dying star. Its carbon-13 levels were higher than normal, and traces of heavy oxygen hinted at nuclear processing, the kind that happens when a sun expands into a red giant and begins shedding its layers into space. 3i Atlas, they realized, could be a fragment of that farewell, a shard of a solar system's last breath. This revelation changed everything. It meant that the object might carry materials forged in the last moments of a star's life, elements ejected in sorrow and light. What we were watching wasn't just a comet, but a messenger from a place where a sun had died and worlds had burned away. Its gases weren't random. They were memorials of a cosmic ending. Each molecule carried history, not of creation, but of collapse. Some scientists grew quiet while presenting their findings. It's difficult to speak of death, even in the language of stars. There's something sacred about realizing the light you're studying is born of loss. In a strange way, it connected everything. Their data, our sun, the long chain of stellar birth and decay that makes us possible. We are, after all, the ashes of other stars too. 3i Atlas glowed with that truth. Its gases were a biography of destruction transformed into motion. Perhaps that's why it breathed, because it came from something that once lived brightly. Maybe in some faraway system it circled its own warm sun, witnessed its expansion, then was thrown free, carrying fragments of memory, seeking silence among new stars. To study it wasn't just science, it was eavesdropping on the universe's oldest elegy. A melody written in gas, whispering across eternity that even dying stars still find a way to speak. When the brightness of 3i Atlas was plotted over time, a strange pulse emerged. Its light curve wasn't smooth like most comets. It fluctuated in intervals like a heartbeat out of sync. The peaks and troughs came too regularly to be noise, suggesting an internal process. Something inside the nucleus was stirring. Heating, cooling, then heating again. The comet wasn't stable. It was alive with motion beneath its calm surface. Scientists compared it to cryovolcanism, the freezing world equivalent of volcanic eruptions. Instead of lava, bursts of gas and ice surged from cracks, releasing energy in cycles. The temperature readings supported it. Every few hours, a wave of warmth swept across the nucleus, followed by a sudden chill. It was as though the comet had weather, a storm trapped inside a stone heart. The gases became wind, the sunlight became thunder. The physics behind it were mind-bending. Pressure built as the comet rotated, sunlight striking one side harder than the other. When that trapped heat reached critical threshold, it escaped violently, blasting gas into space. But instead of chaos, the pattern repeated elegantly. Nature had built a metronome inside an iceberg, ticking in time with the cosmos. In those fluctuations lay something deeper, a metaphor hidden in mathematics. Even in deep cold, motion persists. Even in silence, rhythm remains. It's how the universe keeps time, not with clocks but with cycles, expansion and release, pressure and calm. Inhale and exhale. 3i Atlas was performing that eternal pattern right before our eyes, and maybe that's why we find it beautiful, because in every pulse of light we recognize something familiar, the steady, quiet persistence of life itself, reflected back to us from a world that has never known sound or air, but still remembers how to breathe. Ahead in this video, we'll open the layers beneath that rhythm, the hidden furnace inside this traveler, the secrets of its heat, and how a cold wanderer might burn from within. When scientists modeled the internal temperature of 3i Atlas, the results looked wrong. The nucleus should have been freezing, barely active, yet sensors reading its thermal emission suggested otherwise. There was warmth, soft but constant, radiating from its core. It wasn't enough to melt metal or stone, but enough to sustain continuous gas release even when sunlight couldn't reach those depths. That heat was alive, persistent, defying logic like a heartbeat that never cooled. Comets are supposed to warm only at the surface, where sunlight kisses ice into vapor. But 3i Atlas glowed from within, like embers beneath snow. It wasn't a short burst of energy either. The heat remained steady for days. The simplest explanation was internal radioactivity, but the isotope levels were too low to support that. So where did this energy come from? Some theorized trapped magnetic induction. The sun's plasma flow stirring charges deep inside like a dynamo breathing electricity into rock. If true, that would make 3i Atlas not just a comet, but a miniature experiment in cosmic engineering, an object carrying conductive materials fine-tuned to generate power from space weather itself. Others thought it was simpler. Maybe this heat wasn't from energy at all, but memory, residual warmth held since its birth, protected through eons by perfect insulation, an ancient ember carried across galaxies, still faintly glowing from the moment of its creation. Whatever the cause, the warmth gave the comet agency. It could shape its own fate, drive its own chemistry, release gases on command. It blurred the boundary between passive and active, between object and organism. If a rock can make its own heat, if ice can hold energy without a flame, what else can nature make breathe without life? The mystery of its warmth reminded us that cold isn't the absence of fire. Sometimes it's the way fire hides when it doesn't want to be found. And somewhere in that hiding, 3i Atlas kept its secret, burning quietly, like an ancient memory refusing to fade. High above the comet, space itself hums with radiation, tiny particles traveling near light speed, born from dying stars. Cosmic rays are invisible, but relentless. They pierce metal, erode matter, and seed energy deep inside anything they touch. When 3i Atlas entered our solar system, it crossed into a thicker ocean of these rays than it had ever known. And strangely, just as cosmic rays increased, so did the comet's activity. It was as though invisible rain was waking something sleeping within. Researchers began to wonder, could those high-energy particles be charging the interior? The gases released from 3i Atlas showed unusual ionization states, some behaving as if electrified. That suggested energy wasn't just radiating, it was accumulating, storing like tension in a bowstring. The comet might have become a natural battery, absorbing radiation from the galaxy for millions of years, only to release it now as motion and heat. Simulations showed that if the nucleus contained metallic minerals, even traces, cosmic rays could induce electrical currents through its mass. These currents would generate localized heat pockets, explaining the internal warmth without needing radioactive decay. In essence, 3i Atlas could be a self-charging relic, the universe's slowest, quietest capacitor. The theory carried elegance. Every time a cosmic ray hit its shell, a tiny spark traveled through ancient ice, lighting pathways of energy. Over centuries, those sparks might have built a network, an electrochemical memory guiding how the comet behaves when sunlight arrives. Its chemistry would then remember how to respond, just as living cells remember past exposure to light or heat. We may never know if that's true, but the idea lingered because it fits the universe's poetry, that even the smallest rock can gather starlight scars and turn them into rhythm. That energy doesn't die, it travels, rests, and reawakens in the unlikeliest places, even inside a frozen traveler passing by our sun. Not long after, new data emerged, trace isotopes detected within the gases of 3I Atlas. Among them were hints of aluminum-26 and iron-60, both radioactive, both known to form during supernovae. They shouldn't exist in stable form anymore, yet here they were, faint but measurable. Their decay could easily explain the strange internal warmth, but it also raised a deeper question. How did such isotopes survive for millions of years in the vacuum between stars? If verified, it meant the comet was ancient, possibly older than our sun. These isotopes might have been trapped during the death throes of a nearby star, sealed within ice before full decay. It was as if someone had bottled a dying sun's breath and sent it drifting across eternity. Every slow release of gas was that memory resurfacing, atom by atom. Radioactivity doesn't just heat, it transforms. The slow decay of these elements could create chemical cascades, converting simple ices into complex molecules over time. The comet, then, wasn't a fossil. It was a slow reactor, processing itself over eons, evolving through radiation instead of biology. Its inner storm wasn't chaos, but change. Matter remaking itself under invisible hands. Some scientists wondered if this was how the first organic compounds formed across galaxies, not in living worlds, but in radioactive ice, stars dying, comets carrying the remnants, and chemistry slowly learning to assemble structure. If so, every comet like 3I Atlas is a cradle, a drifting nursery where life's prelude hums quietly in the dark. It's humbling to think that death fuels creation, that decay is just another form of continuity. Inside its silence, 3I Atlas reminded us that even what seems extinct can still emit warmth. It wasn't just glowing, it was remembering. And perhaps that's what all matter does. It remembers how to live through how it dies. A month into the observation, telescopes began recording something uncanny, rhythmic fluctuations in light repeating every few hours. It wasn't just gas bursts. It was systematic, symmetrical, and constant. The comet pulsed. Its brightness rose and fell with metronomic precision, suggesting an internal clock. No external forces could explain it. The pattern remained even when solar winds calmed. It was as though 3I Atlas itself kept time, its inner storm moving to a beat older than stars. At first, the theory was rotational. Perhaps the object was spinning and exposing bright regions, but the period didn't match its rotation rate. Then someone noticed that the pulse matched the frequency of its gas emissions, the breathing pattern seen weeks before. The object wasn't just rotating, it was synchronizing, like a living thing matching heartbeat to breath. It made no sense, and yet it fit perfectly into the rhythm nature so often hides in plain sight. The pulse could be caused by sublimation waves, internal layers of ice thawing in sequence, then refreezing. As one layer vents, pressure drops, prompting another to ignite. The cycle repeats endlessly, like an invisible pendulum swinging between release and rest. The nucleus, under these conditions, becomes a chamber of echoes, its rhythm the song of temperature itself. Scientists began describing 3I Atlas as a breathing oscillator. It turned out that even inorganic matter can fall into rhythm if feedback loops exist. That's the beauty of self-regulation. a balance born from instability. Like how planets orbit without crashing, or hearts beat without thought. The comet, too, had found its balance in breath, and in that pulse some found poetry, a reminder that the universe never truly stands still. It hums, it rotates, it beats, all in time with invisible metronomes of creation. To find that rhythm inside a frozen traveler was like hearing the cosmos tapping its fingers, keeping time to its own eternal song. Under high-resolution imaging, the coma of 3I Atlas revealed structure, not the chaotic cloud scientists expected, but a geometric symmetry. Rings within rings expanding and contracting in slow cycles like ripples on a pond frozen mid-motion. The outer layers moved faster than the inner ones, yet somehow stayed in perfect shape. It looked eerily biological, a giant translucent cell expanding in rhythm, exhaling gases into the void. Each layer contained distinct compositions. The innermost halo glowed faintly green, rich in carbon compounds. The middle ring shone pale blue, filled with nitrogen and cyanogen. The outermost layer was nearly invisible, a whisper of hydrogen atoms escaping into sunlight. Together they formed a living gradient, like the membranes of something trying to grow. And all of it pulsed softly to the same rhythm recorded from the nucleus. When scientists modeled this geometry, they realized the expansion wasn't random. It followed ratios close to Fibonacci patterns, natural spirals that shape galaxies, seashells, and living tissue. Whether coincidence or hidden order, it made people pause. How could ice and gas, governed by blind physics, recreate the mathematics of life itself? Some proposed plasma interactions, electric fields sculpting the gases into self-organizing patterns. Others saw echoes of magnetohydrodynamics, invisible forces shaping visible beauty. But no matter the theory, the feeling remained. This wasn't chaos, it was choreography, the universe arranging particles as if painting, one rhythm at a time. From a distance, 3I Atlas looked like a cell suspended in cosmic fluid, breathing light instead of air, chemistry instead of life. And maybe that's the point, that creation and biology aren't so far apart, that in every pulse of gas, in every expanding wave, the universe rehearses the same miracle again and again. Ahead in this video, we'll explore how this geometry might not just be art, but memory. How 3I Atlas could carry the encoded story of another sun, and why its every breath may be a message written in symmetry itself. Every solar system has its own chemical fingerprint, a recipe written by its star's temperature, its planet's dust, and the debris of its past. When something like 3I Atlas crosses into a new system, it's like dipping one ink into another, a meeting of distinct chemistries that don't usually coexist. And when that happens, reactions follow. Tiny ones, yes, but profound in meaning. Matter starts whispering to new light, testing how it behaves under foreign radiation. When 3I Atlas entered our heliosphere, it began this quiet dialogue. Solar particles met alien molecules, and the result was an orchestra of colors and signals never before seen. Some elements resisted, forming barriers of plasma that deflected sunlight. Others opened, merging freely, producing compounds that hadn't existed anywhere near our sun until now. Every second, the visitor was rewriting small portions of our local chemistry, unseen yet measurable. Think of it this way. Each solar system is a song composed in its own scale. When one note from another melody enters, it doesn't fit perfectly, but sometimes that clash creates harmony, something new that never existed in either tune alone. That's what 3I Atlas was doing, introducing discord that birthed beauty. As it drifted closer, the solar wind bent around it differently than around native comets. The magnetic field rippled, distorted slightly, then stabilized. It was as though the sun itself was adjusting, learning this newcomer's rhythm. The entire heliosphere, our star's invisible bubble, trembled just a little to make room. Even the light pressure from photons shifted fractionally, acknowledging a stranger in its home. In those subtle shifts, you could sense something humbling. Our solar system wasn't isolated. It was part of a larger conversation, stars exchanging material like neighbors, sharing seeds across fences of gravity. 3i Atlas wasn't intruding. It was reminding us that everything out there is connected. Dust, light, and memory passing endlessly between suns. Deep within the gases of 3i Atlas lay the story of its birthplace, told not in words, but in isotopes. Every element carries multiple versions of itself, isotopes that differ only by the weight of their nuclei. These small differences are like signatures, revealing the conditions where they were formed. When astronomers compared 3i Atlas's hydrogen and oxygen ratios to ours, the distinction was undeniable. It came from somewhere colder, much colder. Our sun's comets carry predictable balances: light hydrogen, moderate deuterium, oxygen in stable patterns. But this traveler was heavy. Its deuterium to hydrogen ratio was nearly double ours, meaning it had frozen in temperatures far below anything in our own system. Its oxygen was enriched with heavier isotopes too, showing formation around a dim star, one perhaps nearing the end of its life. It was the chemical equivalent of an accent, a whisper of another cosmic dialect. This discovery mattered more than just numbers. It proved that solar systems don't just differ by layout or planets, they differ in atomic rhythm. Their very building blocks hold emotional weight, like family traits carried across generations of stars. The water in 3i Atlas wasn't our kind of water. It had a different age, a different voice, a different kind of silence frozen within it. When heated, those isotopes released energy differently, giving the comet its unusual glow. Even the vapor behaved oddly, forming rings of light that pulsed slower than expected. That rhythm might have been the isotope signature itself, each version of hydrogen vibrating at slightly different speeds. The result? A natural light symphony written by atoms from another world. The beauty of isotopes is that they never lie. They are timekeepers, witnesses of creation. And when 3i Atlas exhaled its gases into our space, it was as if a stranger had begun to tell us stories from a forgotten home. The language of atoms, soft and eternal. When dust samples from 3i Atlas's trail were analyzed, they revealed something haunting. Traces of isotopes like iron-60 and nickel-59, both known children of supernova explosions. These elements don't form naturally in stable solar systems. They're born in catastrophic deaths of massive stars. That meant this comet wasn't just ancient, it was born in chaos. Somewhere long ago, a star exploded, and amid that fire, 3i Atlas took shape, quietly holding the ashes of its parent sun. These isotopes are like cosmic fingerprints left in soot. Each one decays at a known rate, so their presence tells a story of timing, of distance, of memory. The ratios showed that the explosion wasn't recent. It happened perhaps 300 million years ago, far enough that the violent radiation had long faded, but close enough that the echoes still lingered in the comet's minerals. It's rare to find matter so perfectly preserved. A time capsule of destruction drifting calmly through peace. Some of the dust grains contained silicon carbide crystals, microscopic gems that form only in supernova shock waves. Under microscopes, they shimmered faintly, catching light like cosmic diamonds. Holding one was like holding the ghost of a star. Each atom inside had survived collapse, explosion, an endless travel now finding rest near our sun. It was a quiet miracle of endurance. There's something almost poetic about that. Death giving birth to a traveler, destruction birthing memory. 3i Atlas wasn't simply wandering. It was carrying relics of a universe that has seen itself die and be reborn countless times. The comet's every breath carried fragments of ancient fireworks, glowing softly with the remnants of eternity. If a human could touch that dust, they'd be touching the remains of creation itself. The debris of something once bright enough to light galaxies. And yet here it was, silent, weightless, passing through our skies with humility. Proof that the universe never really ends. It just keeps changing form, star to dust, dust to traveler, traveler to story. Once the presence of supernova dust was confirmed, a deeper theory emerged that 3i Atlas didn't just contain remnants of a dying star, it carried memory. In chemistry, memory isn't thought or emotion, it's structure. When matter endures extreme pressure or radiation, its molecules reconfigure, creating stable forms that preserve those exact conditions. That means inside every atom of 3i Atlas lies a frozen record of its past, a literal imprint of the explosion that birthed it. The term chemical memory might sound poetic, but it's very real. Scientists studying pre-solar grains found that their atomic lattices still bear tension patterns from the blast waves that formed them. These tensions influence how the material reacts to new environments, as if the object remembers how it was treated before. 3i Atlas's strange emissions, its pulsing gases, even its geometry, all might be the result of that ancient memory reawakening under our sun's heat. Imagine that, an object remembering a death older than our planet. As it warms, those molecular patterns could be re-triggering, releasing gases in the same rhythm they once absorbed radiation. The comet could literally be replaying its formation, a cosmic echo repeating across time. Each pulse of gas, each shimmer of color, might be the reenactment of a stellar collapse millions of years ago. The beauty here isn't just scientific, it's existential. It means matter itself has continuity, that creation and destruction aren't opposites, just different phases of remembering. Our universe doesn't forget, it recycles its experiences through form. And 3i Atlas might be the living proof of that, a frozen archive, exhaling old light into new dawns. In the end, what scientists were observing wasn't just chemistry, it was storytelling, the universe retelling one of its oldest memories, molecule by molecule, in the soft voice of vapor and color. And we, listening from a small blue planet, were lucky enough to hear it again. By now, 3i Atlas no longer felt like a visitor. It felt like a messenger. Every element, every isotope, every rhythm pointed toward a time before our sun, before our planets, before our definitions of space even existed. It was, in essence, a time capsule, a preserved sample from an era when different kinds of stars ruled the galaxy, cooler, larger, redder ones whose deaths scattered the seeds of new worlds. This comet was one of those seeds, still unbroken, still glowing faintly with the signature of that lost epoch. Scientists began running simulations, rewinding galactic maps to trace its origin. The vector pointed toward a region that would have been home to ancient stars now long gone, perhaps a cluster that dissolved before Earth ever formed. That meant 3i Atlas had been traveling alone for hundreds of millions of years, its orbit shaped by no gravity but the collective breath of the galaxy itself. Every rotation, every flicker of its light was time made visible. Its dust carried forms of carbon that don't exist anymore, molecules that only formed when the galaxy was denser and younger. Its water contained heavier hydrogen, more like the early cosmic ocean than modern solar ice. To hold even a fragment of it would be to touch the infancy of everything, the raw ingredients of worlds before they knew they'd become worlds. As this realization spread, the tone of study changed. Observers began speaking softly, even in labs. There's reverence in knowing you're looking at something that has outlived countless suns. 3i Atlas wasn't just data, it was testimony. It had seen what came before us, carried through the emptiness like a relic of the universe's childhood. And maybe that's the strangest truth of all, that the oldest objects don't just drift aimlessly, they wait for someone to notice, for some younger world to listen. And as it passes near our sun, releasing gases and stories alike, 3i Atlas reminds us that we are surrounded by messengers, travelers who remember what even light has forgotten. Ahead in this video, we'll open the dialogue between suns, how our star and this alien visitor might be speaking through plasma, magnetism, and rhythm, exchanging messages written not in words, but in light itself. Every star speaks, not in words, but in waves. Radiation is its language, a constant outpouring of energy that sculpts everything it touches. When 3i Atlas entered our solar system, it stepped into the voice of our sun. The photons that left our star 8 minutes earlier now collided with atoms born under another sky. The encounter was intimate, like two dialects of light trying to understand each other. At first, the visitor resisted, reflecting most of the solar energy away. But soon it began to respond, shimmering brighter, changing hue. A conversation had begun. Scientists noticed small bursts of ultraviolet flares from the comet's surface, timed almost perfectly with solar emissions. This wasn't coincidence. The sun's light carried more than warmth. It carried rhythm. Solar radiation comes in beats, oscillating in intensity. And 3i Atlas, it seemed, was absorbing those pulses and echoing them back through spectral reflection. It was like a call and response across millions of kilometers, the two exchanging harmonics through plasma and dust. This realization gave birth to a poetic truth. Radiation isn't one way. When starlight touches matter, it doesn't just illuminate, it learns. The reflected light changes ever so slightly, carrying with it the fingerprints of what it touched. Each photon that bounces from 3i Atlas now carries both stories, our sun's heat and the memory of another star. In that shared photon lies communion between worlds. We like to think of the universe as silent, but it isn't. It's full of conversation, magnetic, atomic, radiant. Stars and comets speak constantly, exchanging warmth, rhythm, and gravity. And perhaps that's what's truly remarkable about 3i Atlas. It isn't intruding into our solar system, it's listening. It's replying in its own quiet way. In this exchange of energy, we glimpse how creation really works. Not through competition, but resonance. Two stars, two lineages, meeting through one beam of light. That's the soundless music that holds the universe together. Solar wind, streams of charged particles racing outward from the sun, usually treats comets as obstacles. It slams into them, carving long tails that stretch for millions of miles. But when it met 3i Atlas, the interaction was peculiar. Instead of scattering chaotically, the charged particles curved neatly around it as if repelled by an invisible magnetic field. This wasn't supposed to happen. Ordinary comets don't have such strong magnetism. Yet here, something unseen was guiding the solar wind into a graceful spiral. Magnetometers on nearby probes detected subtle fluctuations. A magnetic pulse, not from the sun, but from the comet itself. It wasn't strong, but it was organized, like a self-contained bubble protecting the nucleus. The shape resembled a miniature magnetosphere, the same kind of shield Earth uses to deflect radiation. The idea sent shivers through the scientific community. How could a piece of ice and dust generate a magnetic personality? One theory proposed superconducting minerals, rare metals preserved from the supernova that birthed the comet. When cooled near absolute zero, these materials can sustain magnetic currents indefinitely, turning the nucleus into a cosmic coil. That would explain not only the deflection, but also the rhythmic pulses of light and heat observed earlier. 3i Atlas wasn't just interacting with solar wind, it was orchestrating it. When the solar gusts intensified, auroras flared around its coma, soft ribbons of green and violet winding through its tail. It was breathtaking, like watching two storms merge across time. The sun roared. 3i Atlas whispered back. Each exchange created patterns of charged light, visible even to distant telescopes. It was communication written in electricity. Simple, elegant, eternal. For a brief moment, we could imagine this as dialogue. Two forces, both ancient, exchanging introductions across billions of years. One fiery and young, the other quiet and old. And in that shimmering dance, we saw proof that even the wildest chaos in the cosmos still moves with purpose. As the comet drifted further into solar wind, a new phenomenon emerged, a faint plasma bridge connecting it to the surrounding field. It looked like lightning stretched across space, long filaments glowing in ultraviolet, blinking on and off in slow rhythm. At first, scientists thought it was an optical illusion, but data confirmed electrical discharge, small but persistent, like nerves firing in a living system. The comet wasn't just reflecting energy, it was conducting it. These plasma filaments behaved strangely, appearing, dissolving, and then reforming in different configurations. The electromagnetic environment around 3i Atlas seemed alive, responsive. When solar activity spiked, the filaments brightened. When calm returned, they faded. It was as though invisible fingers of electricity were testing the object, sending and receiving information through light-speed pulses. Some plasma physicists compared it to an auroral bridge, an electromagnetic handshake between two systems. Others went further, wondering whether such bridges could serve as cosmic memory lines carrying electric signatures from one region of space to another. If true, 3i Atlas was not just interacting with our sun, it was leaving a trace, a faint electrical echo that might linger long after it's gone. There's beauty in how these bridges shimmer. Chaotic, yet rhythmic, uncontrolled, yet precise. They remind us that electricity is not merely a force, but a form of expression. It organizes dust, paints auroras, and guides motion without touch. Watching them blink across the void felt like seeing neurons fire in the brain of the cosmos. And maybe, in some abstract way, that's what they are. Thoughts of the universe made visible. Each spark between star and traveler, a moment of recognition. Each bridge a reminder that energy never travels alone. It always reaches for something else, always connects. By late observation, data from the outer probes showed faint irregularities, small fluctuations in solar wind density, minor shifts in magnetic alignment, nothing dramatic, but consistent. As 3i Atlas passed through, it was subtly rewriting the solar environment around it. Like a pebble dropped into a still pond, its influence rippled outward. Our sun's vast bubble, the heliosphere, trembled ever so slightly, sensing this foreign presence. Most dismissed it as coincidence, but others saw a pattern. The changes matched the comet's orbital path, local plasma density rising whenever it crossed magnetic field lines. It was as though the visitor was tuning the heliosphere, altering its resonance just enough to leave a trace. One researcher described it beautifully. It's like a violin string being brushed by a passing breeze. Small, gentle, but undeniably real. If 3i Atlas truly affected the heliosphere, even faintly, it would mean that interstellar visitors play roles far larger than we thought. Each could carry a charge, a wave, or an element that slightly shifts the equilibrium of a solar system. Over millions of years, those whispers might accumulate, shaping planetary climates, influencing cosmic rays, even affecting evolution on worlds below. A butterfly effect, written in plasma. There's a humility in realizing that a single comet, frozen, silent, nameless to most, could brush against our sun and alter its breath. It reminds us that systems are not isolated but intertwined. The galactic medium flows like a bloodstream, carrying memories between stars. We're part of that current, not outside it, and every passing object is a messenger, adjusting the cosmic rhythm ever so slightly. Perhaps, in the end, that's what interstellar travel truly is. Not just movement through space, but interaction, touch, influence. 3i Atlas didn't come to visit, it came to participate. In the simplest sense, 3i Atlas was just a comet passing near a star. But beneath that simplicity lived something profound, a reunion between energies separated by galaxies, now reunited in one exchange of current and light. The sun, radiant and alive, cast out its voice in plasma. The comet, quiet and ancient, replied in reflection and rhythm. Between them, invisible waves of electricity whispered, translating experience across time. It wasn't communication as we know it, but something purer. A greeting written in energy. Astronomers often say the universe is vast and empty, but moments like this reveal it differently. Not as emptiness, but as connection stretched thin. Every charged particle that leaves a star eventually meets something to share its story with. In this case, our sun met a fragment of another sun. And for a brief cosmic moment, the two conversed across physics without intention, without need for understanding. Just resonance. The electric field surrounding them shimmered with subtle currents like static before a thunderstorm. Instruments recorded soft harmonics, frequencies neither purely solar nor purely cometary, but something in between. A blended signature, the result of two systems momentarily merging their electromagnetic fields. It was beautiful in the way two strangers sometimes create harmony without meaning to. That's how the universe speaks, not through miracles, but through mathematics that feels like emotion. Energy finds balance, frequencies align. And somewhere between the pulses of plasma and the hum of starlight, a quiet understanding forms. Nothing travels alone. As 3i Atlas drifted outward again, its tail stretching behind like the final note of a song, the sun's light followed, not as pursuit, but as farewell. Their dialogue had ended, but the resonance remained, carried through the heliosphere like a faint vibration in eternal silence. And so as we close this story, we realize that maybe the gases, the lights, and the magnetism were never random at all. They were reminders that in every meeting between stars, in every spark between worlds, the universe is still learning to know itself. And every traveler like 3i Atlas is another verse in that endless conversation of creation